Evening, folks. Look at this. I've had a clear out of one of the cupboards. Found some lined paper. Woohoo! Alright, we are going to do a mix of integration this evening. But the bit that we're going to start off with is what I've always called calculating peculiar areas. Now, I used to teach this to my year 12s back in the day. But we'll go with it because it's in your book. So essentially what we are talking about is that you will get some kind of a curve which we are going to call f of x. You will then get another curve, straight line, anything like that. So I'm going to call that one there g of x, and then you will be given two limits. Which might be 0 and one number, but I'm gonna be a bit more defined on this one. I'm gonna call this one here A, and I'm gonna call this one here B, and then they're going to ask you to find that area there. Okay, something like that. Very occasionally, what will happen is that your two bits will actually, or two curves will actually do something like that, and you'll have to find that point of intersection there, and again it might be that you've got a limit that's 0 potentially, or it might be something else, and they can ask you to find this area just here. So sometimes there's some extra stuff going on, and again I'm going to call this one here f of x, and this one here, this blue one, g of x. However, you will notice that the f of x curve, the black line, is always the one that's higher, okay? And all you have to do is integrate the f of x between these two limits of b and a, and integrate the g of x, oh I should have done that in blue, that's my bad, between the same two limits, and as you always would do, just take it away. Okay, that's it, no biggie. So I have done one for having a little practice. Let me just get myself a nice new piece of paper, and we are going to do that f of x is equal to 2x plus 1, and then I'm going to have that g of x is equal to 4x minus x squared, and then drawing the graph, which I did on Desmos this evening because my calculator's upstairs out of the way. So drawing the graph, we have that this is f of x just here, that's got a value of 1, and then my g of x function, I'm not quite sure I'm going to draw this now, it's so much easier when I did the quadratic one first. It's going to be a bit out of scale, sorry folks. Here's my g of x, lovely negative quadratic. And we are going to find this teeny weeny region just here. Okay, I'm going to stick a capital R in there, hope you can see that okay. So we need to find where they're intersecting just there, and then we're going to do it between 0 and that value. Okay, so first things, I'm just going to go f of x equals g of x. So I'm going to say 2x plus 1 is equal to 4x take away x squared, and then I'm just going to rearrange this quadratic equal to 0, so I'm going to have x squared take away 2x plus 1 equals 0, and then I've written this one so it factorises like so. So we'll get x equals 1, so therefore this point here, this value, this upper limit here is 1, and obviously this is 0 just here. So we are looking at integrating, as I said earlier, f of x between 1 and 0, and then we are going to subtract the g of x integrated, and again between the same two values. Okay, that's what we're looking at doing. Right, f of x was 2x plus 1. I'll have to turn over the page when I do this. So integrating 2x plus 1 dx, taking away the integral of the g of x, which is 4x, take away x squared dx. If you want to do these two bits separately, get your two answers and then take them away. Quite happy for you to do that, doesn't bother me at all. Let's just put my limits on. 1 and 0, 1 and 0 just there as well. I'm going to just put my equals down here. Don't forget it's square brackets, so 2x integrates to x squared plus x, not going to bother putting the plus c's in because they cancel each other out anyway. 4x will go to 2x squared, and then a slightly more awkward one here, x cubed over 3, again between 1 and 0. And sticking the values in, then putting 1 in will give us 1 squared, which of course is just 1 plus another 1. Taken away, sticking 0 in will just give us 0 anyway, so I'm not worried about that. Take away, right, I'm just going to put a big round bracket around those ones. And then again, putting 1 in here will give me 2 times 1, so obviously just 2. Taking away 1/3, and then putting 0 in is obviously just going to give me 0. Obviously we know it's not always the case. So 1 and 1 is of course just 2, so the black bracket is going to equal 2. Taken away, and the blue bracket, 2 take away 1/3 is 1 and 2/3. I'll just grab a calculator. Sorry, excuse me. Sunday evening. No really like to have mixed brackets anyway. 5/3. Giving me an answer of 2 take away that, 1/3. Okay, so this area here is just equal to 1/3. That's it. Yeah, happy days. Right, I've got to, I think, do some parametric integration in a minute. Good. Let me just turn that over so you can see it right at the end.